that did this, or 4 people? Did you did?
Yeah.
4 people. Awesome. So yeah, please type the version obtainer.version,
So I'm not sure if
and if this work, that would be great because you can now follow through the tutorial. So it's working for everyone that do have. Okay, perfect. And now, did you guys have like some knowledge or experience with Docker? You do?
Yeah.
No. No one? You have a bit?
No, I don't.
No.
No.
Not even.
No.
Okay. So one of the easy thing, if you have already worked with Docker, is basically it uses the same principle, the pull, the build, and so on. But since you do not have experience with, most of you do not have experience with Docker, we just explain the command. So basically, what you do is, I will show you in live, but there is 4 types of command that you need to understand. Is the pull, that will just grab an image from the website and install it inside your PC. Run, so it's obtainer run, allow you to, from an image, run a code inside it. And the exec is the same, but there is one specificity. Exec will run the command line that you are giving it inside the full command, and run will run a first command line that was inside a singularity recipe that we will show you later on. So that's the difference. Run execute another command line that was inside the singularity recipe and the command line that you are giving it. So basically, you use run when you want to execute a command line first and then do something. So typically, when you want to activate a conda environment and then run Python. So this pipeline I will show you later in order to like install the whole thing, and yeah. And the last command that will be the most used is the build command. So how do we build a singularity image? So basically, I can build the name of the image that you want to call it. So basically, image singularity dot sif. This is the extension of the images, SIF, and the either the link of a singularity image that is in the hub. So basically, like Docker, there is images that can be accessed in the cloud, or a singularity file, which is a recipe to create the image, and we will see this like now. So how to create a singularity file from some recipe, and what are the steps inside the recipe to create a file. And basically, the image will be some kind of a small version of your PC. It will be a Linux environment with some package, and basically you can also copy code inside it, but I do not recommend the copy code inside it. And you can also copy data, and also I do not recommend to copy data. To have data and work with data in it, most of the time you do a bind. Basically, you make sure that your image see another repo, basically with a large amount of data, and this binding will allow the image to be able to access to this data without having to copy inside the cluster. So this will be, I will show you guys now. So maybe we'll do 2 tests. First test is, can you guys do the first one? Obtain a pool Docker. So this is using singularity image from the hub. And this will create a file that is called Ubuntu 2022 .04.zip.
So it would run in Mac. No. So this This command will run in Mac.
Yeah. If you have obtainer, if you have you can do obtainer or singularity. If you have singularity in your PC, you can do it. But if you have obtainer, you write obtainer pool, the Docker like it's written. And normally, it will install.
This should be done locally,
And it should be done locally.
not on the cluster.
Never, ever on the cluster. If you do this, I will come back and I will.
Jean-François will come to slap you.
I will be méchant. I will be angry. Hein. I will be very angry. Hein. Because I told you. Hein. So yeah, never on the cluster. Everything is local. You create the image local and then you do you paste your images inside the cluster.
Could you do this command on your laptop or?
Now
Yeah.
I'm too lazy because I will do something else after. I will show you something.
So what is expected from this command? Something is happening, but like what?
Yeah, at the end, you have like something like in the terminal with blue comment, and like you will have like some
Fetching stuff.
Yeah. You have like
Yeah,
it's telling you like it's installing and so on, and at the end, once the process is ready, there is inside the root of where you launched the command a new file that is called Ubuntu 2022. Okay. But you're right. Yeah, I will launch. I will launch it. Right. There is no time to be lazy. Where should I run this? Yes. Run it.
Parce que j'utilise des ressources, hein, je peux le faire en deux. Et de toute façon, faut que je sois mis sur le cluster pour pouvoir juste pour le faire charger tout ça.
So to show that the actual command in live. So should give you those messages telling you like what part of the layer of the images that are built, and once it's built, you will be seeing an image that is called like this .zip, and this is an image, a singularity image, basically a small Linux environment that you can run anything inside it. Okay, and now we will try our first command inside this little image. But first, for those that have like that did this, that do have the same result that I do have, can you try without looking at the slides to run a command inside it, just by looking the documentation, because it's very good it's a good exercise. So you go in the documentation and try to see how do we launch a command from a singularity image.
So what documentation are you talking about?
Obtainer. You go to the obtainer documentation.
Okay.
To run the image or to
Just run a command inside the image. So a basic command, let's say ls inside the Docker.
just a question. When we do this, does this mean that the image is already run on the system or not yet?
I think in our case, it's not like Docker when you pull the images and it's inside your PC. Once you do pull, the full file, the full image is present in this file, in this zip. So we can use it, but it's not used now.
Okay.
So to use it, we need to either use the run or the exec command. It's not like in Docker when you pull the images and it's inside directly and you can like run it inside the background. It's not like this. Oh, sorry guys. So you can try some command line, and as I mentioned earlier, you need to use the exact one. So I will show you now, and I made like some comment at the bottom of the slide. So I can exact the name of your Singularity image, Ubuntu .sif Python 3 version. So Python is actually the command that I want to run inside my Docker. That's it. So let's try. This also should work. IO. Oh. Incroyable.
Works well.
It's not working well.
Est-ce qu'on aurait eu si on avait fait ça?
Okay, so it's to run. It's strange. It's not installed by default inside the images, but
You should have Python, but not Python 3.
let's see.
Because Python 2 was created.
Oh, there is
No.
even no path. Oh.
I tried to use ls and
It worked? Didn't work? Oh, incroyable.
Moi j'ai fait PWD, ça marchait quoi. Mais bon.
Now I'm doing ls and it's working. But you just need to add sudo in the beginning.
Ah,
Sudo to run the command. Okay, so now we install our first Singularity image, and now basically what we can do is we can copy this image inside the cluster to be able to use it. And what we'll do in cluster basically is running those kind of commands without the sudo, because inside the cluster you do not have sudo access, and it's basically inside a bash script that I will show you. It's running obtainer exec or run followed by a Python script. Basically, that's the idea of how we use the Singularity images. And now let's come back to the slides. So we did the first example, and I will show this later on. But yeah, basically what you can do is, as I mentioned earlier, is you can bind some, let's say, large amount of file or data with your cluster without having to copy the file inside the images. Because let's say you have terabytes of data and you don't want to copy all of it inside the image, because the images will then be terabyte of data and you then have to copy this, and it's very troublesome. And if you have to change again the images, so this is very it's not maintainable. So to do this, you bind with the command that I'm showing now, and that I will be showing you later on. So it's basically either the b, the argument with the b, or the bind. this one or this one is the same, those flags. And then what you do is the actual path inside your project, and then you do the path inside the singularity image. And then when I use a script inside, for example a Python script, when I'm looking inside the Python script at data, I will be able to see all the data. And I will show you later on what I'm meaning by this.
One question. The path is the path to the cluster or to our own machine? That
So-
we want to bind to the
One,
image.
it's the first path is the local path inside your working environment. It can be in the cluster or it can be in your image. It can be on your workstation. So let's say you have like in the cluster or in your image you have like a repo that is called images, and inside there is terabytes of data. So you copy this path. It can be inside the cluster or in your local machine, and then you put the two dots, and you put a path that will be present inside your images. But you do not need to create it beforehand. You just put a simple path, which is data, and inside your images, data will be available with the bind of your local data. That's it. Okay.
That .sif file, SIF file that was created. So does that have to be in the same folder locally?
No. I will show you later on like what is my pipeline inside the cluster, and inside the cluster I do have a repo for data, a repo for containers, and a repo for code.
Okay.
And they are not directly, and you just need to have the correct path. That's it.
Okay.
And most of the time you use the absolute path, so you're sure that everything is working correctly.
Okay, because when I'm opening the app terminal, it is going to the root, and the .sif file is being formed in the root somehow. So is the folder is not matching locally.
Yeah. So when you want to use it outside, you just put the full path.
Okay.
And I will show you this. Like I'm using the full path inside the Latin cluster. Yeah, good exercise. First, recipe. So basically, it's like a text file that will be used to create a singularity image, and basically it's an extension that is called DEF, and it's always the same structure. We have Bootstrap, which is used for telling from which environment and platform the actual image will be based. So most of the time it's based on Docker. And then we have from the exact name. So if you go in the Docker hub, there's a ton of images. There's PyTorch images, there's Hugging Face images, there's NVIDIA images, and they have a name. So you just copy the name, like I did. So let's say, since you are like looking at me weird, let's go to the Docker hub. And basically I can take all of those images, and for example I can take this, and the name is this, for example. And I can change any name that I want. I can take the PyTorch, which is like the real image. Typically when you want to work with PyTorch, building from the main images is actually a good idea. You can then just create, you can then install all the package that was needed inside your project, but all the CUDA and PyTorch and all the difficult thing that you need to install is directly installed already. So you just need to pip install inside the recipe that I will show you now, the actual name. So for example, this can be changed in all cases. So inside this is NVIDIA, but now I can copy the thing that I can paste the thing that I just copied. Okay, and for those that do have access to Obtainer, you can create a file, text file, with the extension DEF and copy all of this. Let's go, guys. I will also do it.
I don't understand. What do we copy in the TDF file?
So you copy all of this.
Okay.
And there's normally already a recipe. There is normally two recipe. Yeah, there is the Python ML one that is very simple, which is a base image of Python that we will use later on. And there is the actual Anaconda workflow that is the most important thing that we will see today. So basically what you do is you just create, let's say we call this recipe.def, and you just paste. And the file looks like this. There is also always the bootstrap at the beginning from Docker, the actual name from, which is the name that I just showed you when I was in the Docker hub. Most of the time you use PyTorch images, you can use Ubuntu images, you can use TensorFlow images. You use the thing that will allow you to do the less step inside the Docker, or the singularity images. So for example, if there is like someone that did an image with PyTorch, OpenCV and everything inside it, you can download it, which if it's already in the hub. And most of the time, when you look at the hub, there is guys that tried to like package all the data science library inside an image. So it's always a good start to check the images, or you can start from scratch from an Ubuntu, like I mentioned at the beginning, and then download everything by hand with pip install, or you can do a copy of recommend.txt and then install it inside the. So I will show you this later on.
Before you proceed, sorry, I couldn't follow after making the .si file. So can you, in one or two sentences, like tell what is the use of the .si file? That was
So
great.
the .sif is the actual singularity image. So it's basically the local containerized version of the Ubuntu that we download. So it's a mini version of what we download. And this would be used to directly then run command and use script inside the images. It's like having a local environment that is very compact.
There's a local environment, local operating system.
Yeah, you can see this like this. It's like a local one, which is very compact and it's it's separated from everything. So it works all by itself. Just the file will work just by itself.
Do you have the code of your diapositives? Because I can't copy.
The code, unfortunately, not. It was meant to be copied by hand. That's why it was on purpose. So you have to write.
Okay.
Because you cannot copy.
Because it was long, I thought I wouldn't be able to follow if I.
Yeah. But if you write it, then there is like a much more chance that it will stay in your head.
When we build the image, we can do it on the cluster.
Yeah, it's
No.
it's not running.
J'ai pas fait.
Faut pas faire, hein?
J'ai pas fait.
Technically, you can do it. Technically.
Yeah.
Technically, but
it will take a lot of resources.
it would take a lot of resources, and also root access is not available, and it will mess up a lot of
Yeah.
things. So I strongly encourage you to always create your images locally in your PC.
Maybe you lose insert to this, but on my station in the cluster, I don't have access to Obtainer. So I don't know if it's installed on this partition or not.
That's a great question.
Yes.
Great question. Some of the actual command lines, for example, Git, Obtainer, Docker, cannot be accessed normally. So in your normal session, you cannot have access to Obtainer. If you connect to SSH to local machine inside the cluster, you can. But this, I will not show you how to do this because it's like you will mess up with the cluster then. So that's why I mentioned that most of the time you want to do this locally first. Everything local. And then there is no then. You always do this locally. That's it. And one of the issues that if you just connect on your base, on the cluster, on the session, you cannot have access to Obtainer. So you cannot do it in regular.
Because I have a session on the cluster, but I can't use Obtainer.
No, you cannot access Obtainer.
That's by design.
Yeah.
Okay.
Jean-François made things the correct way.
Yeah.
Okay, so it is working or not? The thing. Maybe we will accelerate a bit. Let's accelerate a bit because. Oh, you have time, guys. So we can go slow, but it will go up to maybe 6.
I have a meeting at 4:30, but with your slides,
Okay.
make it.
So it's up to you guys. If you have time, you can go till 5, 6. If you want to be like in a quick, you want to end this quick, like can end this like in.
So before you accelerate, can you go to
What?
page 14 before you accelerate, like in the presentation?
So you want me to accelerate?
Before you do that, I have one question. Page 14 probably.
This one?
No, it's data binding and mounting directories. Yeah, this one. So
Yeah.
can you just tell what the last command is doing, obtainer exit? Like this is binding the SIF file with the data folder. Like can you
So
just-
the SH file. So now the SH file. Let's call it image. So it's image, and we want to bind a local directory with what it's inside the image. So, and this is basically what we do. First, we create a directory, then we create a CSV inside it, and we want, without having to copy this file inside the image, just create a link with bind. That's it.
Okay.
And so when I run this command, I will be able to access data.
Okay.
I can also use like script that can access data. And in this example, I just copy a CSV, but as I mentioned earlier, it's, let's say you are working with medical images, you have like terabyte of images, you will not copy all the images inside. You will just do a bind with your local repo with your images to the image. So you can connect the your repo of what with the images with your image. It's for just connecting, binding. Those.
Okay. So does that mean that we need not send the data to the cluster?
Yeah, we need. It's need to be present inside the cluster
Okay.
somewhere,
Okay.
and then you do the binding.
Okay.
mesh should be read data in the same.
The container and the data can be elsewhere. Again, like for example, in my case, I have like a repo for data. So I have all my images, CSV, and type of data that I do have. I also have like a repo that is called containers. So I have all the CIF images, recipe, and so on. And then I also have like a repo that is called code, when all my code is present inside. Okay? So let's accelerate a bit. Okay? Yes, I want to accelerate. So no. So before I accelerate, just to make sure that it is clear, the structure of the dev file is the following. We have bootstrap from Docker, the name of the Docker images. Then we have post, which is basically what we want to do inside in terms of installation. So anything that you want to do in terms of installation will be there. You can have the step environment when you add local environment variable, and you can also have a run that we'll see later on, where every time the images is run, it will launch a commit, and we'll see this later. Okay, so c'est bon. Yeah, we can pass to this, but basically Slurm is the one that will be handling the connection between your images and the resources. So it will be able to connect the CPU, the GPU to your code. That's the role of Slurm is basically making sure the resources are scheduled the right way and are given to the right people at the right amount of time. That's it. Okay? Now, please, everyone that do have access to the cluster, can you connect to it? And we will see the basic command that you need to know when using Slurm. So, now I'm still, I think, yeah, still I am in the cluster. So those are the 4 commands that you need to learn by heart, because I did, so you can see. If I did, you can. Okay. So the first one is something also that you need to remember is they all start by S. So SQ, sconsole, srun, sbatch, and SQ is to just see the current job that are currently running inside the cluster. So if I type SQ, I will see all the crazy guys that are running jobs inside the cluster. Okay? So for example, there is guys that are running like a lot of script. I'm also running script now, as you can see. There's my name here. Yeah. So I'm running some stuff. And yeah, question?
No, just the time is like for how long are you running?
Little joke, little anecdote that I can give you now. During my thesis, I was quite greedy, and I did launch quite a jobs, a lot of time, even in the weekend. And because of me, or thanks to me, some rules changed in the cluster. Some rules changed, and before I did like this huge experiment with launching like ton of array of job with like it was a lot, and Jean-François decided to reduce the time of each jobs, because what I was doing is I was preparing a CSV with command line that I can execute automatically with a lot of script with an array that I will show you later on, and basically it was running 10 script, and when those 10 script was ending, I was running automatically 10 other script. So I was taking the place to other people, and at the time jobs could run up to 48 or 72 hours. So it was a lot. So you took basically a lot of resources during a long time. So then Jean-François decided to reduce this to 24 hours. So the window is, you can take a lot of resources, but it will be just for on a small amount of time. And then Slurm basically will, it also added something that if you did a lot of jobs, it will give you less chance to have access to other jobs. So in order to redistribute the resource to everyone.
24-hour limit is a hard cutoff. So if your script goes for longer than 24 hours, it will shut down. Or is there like a queue system where it pauses what you are doing to run some other scripts and it can?
There is basically you can do this, but it's like it's way out of the scope of the
So that's hard to
Yeah, yeah. So linked to the question of colleague here, to see how many hours do have a machine on. So for example, most of the GPU you have 24 hours. And to see this is you use the command line sinfo. And sinfo allow you to check all the available machine inside the cluster. So CPU, GPU wise, the node and the name of it, and how much time you can run on it. And also there is, like I will show you now, there is the state, which if it's mixed, you can use it. If it's idle, you can use it. And if it's down, the machine is down. So you need, Jean-François need to reboot the images so you can use it. So basically in the cluster, we have access to all of this. As you can see, there is quite a lot of device. And inside node list, there is a node, and inside this node, there is multiple GPU. Okay?
So node is not just one single GPU. It's
No. Node is basically
cluster of GPU.
4, 6, 2, sometimes 8 GPUs. And some nodes are linked with hard link to make sure that our code see GPU with 86 gigabytes. So he made this, Jean-François made this to make sure that we do not have GPU with 86, but we have, for example, 2 GPU with 48, and then he bind those with it's some Slurm script to make sure that those are unified memory. But yeah, that's basically what is done behind the scene. So all of these are basically the GPU that you can have access to. And also we talked about GPU, but we also want CPU access. For example, if you have jobs that do not require GPU and you just want to run processing, most of the time you will use those named server CPU and CPU1, CPU2. And inside the Slurm script, you will be using this name. And there is a lot of device, so you can run an array of 100 of script. So what you would maybe, it will took maybe on your local machine 3 months to run. In the cluster you can run it in 2 or 3 hours. So the amount of time that you gain is tremendous. So it's very it's skill of learning how to use the thing is very worth it. And as I mentioned, most of the GPU have 1 day limit. The GPU that are less memory, the 11 gigabyte are 2 days. So as you can see, time limit is 2 days for the 11. And for the CPU, some are 4 days and some are 10 days. So for pre-processing, it's allowed to have a long run, but since there is 100 and more than, I think there is more than 600 machine with correct GPU inside the cluster, so you can run do your hard content inside it. Okay?
So one quick question, how to know the number of free GPUs that are which number of GPUs are free, so that.
That's a good question. The first question, the first one answer is this. You go you tap S-info, and then you will see. And when you see idle, it means that there is no GPU that is used. When you see mixed,
Yeah.
it means that some of the GPU inside this node are used, and there is another thing to be more precise, and it's basically doing SSH associated to the node. So if I remember correctly, so I have the command somewhere, but you know, sometimes you forget. So SN. So it's basically the name of the node, SSH the name of the node, probably, and you can have access to the node. Maybe. Yeah, that's the. Yeah. So for example, can have access directly to what is inside the node. And now I'm connected inside the machine. And now typically I can run NVIDIA SMI to see usually this work and you see all the GPU that are available. But now, most of the time, when this is not working, you need to just sometimes there is some issue with drivers and you just need to reboot the images. So even in your PC, sometimes when you type this, it will not work because drivers issues. Yeah. And basically what you do is you connect to the specific node and you tap NVIDIA SMI. But I'm sure if we try another one, it's not S and go, S info, guys.
So how did you log out from the machine?
I will show you. I will show you again. So as you can see, maybe we can go to like SN 58. Let's see if we have like luck, or maybe SN 18. Maybe we have luck. So the idea is SSH, SN.
No, I am at 18. You can't go there. I am logged in at 18.
Are you logged?
Yeah.
And then to see if there is, just type your password, the same that you have in the cluster.
My question was opposite. Then how do you log out?
Exit.
Exit.
Didn't. Yeah. Wait. Sorry.
Yeah.
Okay. Maybe this time. Look. Then let's NVIDIA. Look. So in this case, we just have one GPU in this node, and basically you can see that this GPU is not used because the memory is not used at all. Okay. Okay, so now what we will do is we will